All right, great. Welcome everybody for Advanced Air Mobility Airspace Working Group Kickoff. This is one of the series that we are kicking off many work groups, aircraft, community, cross-cutting, and airspace. So this is one of the exciting kickoff days for airspace. We have a fantastic panel lined up, a team of experts who will be answering your questions as well as offering their views about airspace integration. So before we get to the panel, please allow me to go through some basic charts and material that we have prepared in anticipation of the working groups. So our kickoff agenda is a quick introduction, and I won't try to take 20 minutes, but this is to welcome you all attendees, sharing the agenda for the day, introducing the leads, which is Dr. Tommy Daniels and myself. We will be basically asking you to offer us some questions, and we will moderate the questions and lead you to some interesting discussion points. And we will discuss the path forward from here on. Our panelists will include experts from Airbus, Akin Gum, Commercial Drone Alliance, DoD, FAA, Hyundai, NBA, and Uber. The bottom line that we see that needs to change is airspace system has to be ready when the vehicles are ready. In the past, the vehicles get certified and then we figure out how to enable them and give them access to the airspace. Now, with the emergence of new entrants, we really need to focus on simultaneous preparedness of vehicles as well as the airspace system. So, as soon as the vehicles are certified and ready to operate, airspace system is able to accommodate them at the scale that is possible, along with other operators and other operations that are coexisting at the time. So main mantra here is airspace system should be ready when the vehicles are ready. So in order to make sure that airspace system is ready, we would like to understand the research issues and ideas and questions that come up that we need to address ahead of time as the systems engineering for the entire ecosystem, aircraft, airspace, and infrastructure is considered. You will be able to ask many questions through our conference.io site. You will see a web address below here on this chart. Also, it's on the registration site, and it's also given on the YouTube link there. So you can just click on the link and start asking questions. And the questions that are rated high will bubble up in their priority and we'll consider them first. Once we look at the urban air mobility, advanced air mobility landscape, we have identified 5 different pillars. 2 of them are related to airspace. The number 3 pillar, which is related to the airspace system design and implementation, that includes the design aspects, the rules, procedures, the roles, communication, navigation, surveillance infrastructure, and UAM port or the vertiport design. So we have experts in the panel who are going to talk about the CNSI as well as the rules, procedures, and air traffic operations. Then on the airspace and fleet operations management side, which is pillar number 4, we look at the airspace operations and interoperability, interaction with other traffic, efficiency, scalability, resiliency under disturbances such as weather, management of the entire fleet, and prediction of the weather and its use for better planning and execution and operations in the airspace. So today, in this work group, we are going to talk about these 2 pillars. And our expert panelists will cover information addressed in these 2 pillars. So pillar 3, which is airspace system design, focuses on the design, regulatory aspects, the management of the airspace, and the supporting facilities as well as infrastructure to ensure safety, efficiency, and reliability of these operations. So what are the types of design considerations we need to consider? Rules of the road and arrival departure streams, any procedures, and the roles, responsibilities, as well as the communication, navigation, surveillance, information architecture, and vertiports and UAM port design aspects, the length and the width of the ports, how close they can be, how could they operate independently, dependently, and so on and so forth. In number 4 pillar, which is airspace and fleet operations management, we look at airspace operations services. What kind of services are needed to ensure the safety, efficiency, scalability, resiliency of operations at large. Also look at fleet optimization and information about challenges that they could pose, such as the weather and unexpectedness, and what do you do when you experience certain type of weather. In terms of our working group, as we kick off the working group today, we will be starting the work group discussions with you all's participation. We'll have one working group. It's going to be open to public. All information will be accessible to public. The goal of the working groups at the end of all the working groups actually that NASA is kicking off is to contribute towards book of requirements and guidelines. The idea is that lots of entities are doing research and partnerships. So we would like to bring all the information related to what we know about airspace operations, the concepts, the validation, different procedures, and how do we make sure that that information is available to everybody. The working group leads, Dr. Tommy Daniels and myself, we will be kicking this off and will be helping you throughout the process. And Cecilia Town, who has done a remarkable job, she's been coordinating with you as well, along with Anna Kowalowski, who are going to be helping us through the logistics and operations and making sure the working groups move very smoothly. So our kickoff panel today consists of Rob Eagles from Airbus UTM and Jennifer Richter from Akin-Gump, Lisa Elman from Commercial Drone Alliance, Brent Ingram and Colonel David Bennett from DoD, Mr. Bill Stanton and Scott Rosenblum from FAA's Air Traffic Organization, Diana Cooper, Head of Policy at Hyundai, UAM, Heidi Williams, who is Director of Air Traffic Services at NBAA, and Tom Prevost, who is Director of Engineering for Airspace Systems at Uber Elevate. I will give you formal introduction as well, but I just wanted to give you a preview of the wonderful panel that we have. Let's look at a couple of events that you might be interested as we move along once we kick off the work group. The very first thing we are going to do after the work group kickoff will be on June 25th. We'll be discussing the concept of operations for Pillar 1 and 2, which is focused on the aircraft, and then UAM concept of operations, which is also aircraft focus at large. And then in July, we will be talking about the airspace focus, Pillar 3 and 4, as you saw, concept of operations. So we would love to get your feedback on all of these aircraft, as well as airspace, as well as community integration pillar, which is number 5, which will happen on July 10th. So we have a number of events that are coming up, which is where we would be sharing with you our research and what the thinking that we have done towards concepts, and love to engage with you all in the working group manner to get your feedback and figure out what the next step should be in terms of the research, as well as any analysis that we have to do. So again, you will see the question and answers at this conference IO site please feel free to ask questions, and then we will do as best as possible to address all of them, but at least we'll address the ones that are ranked highest. So that was end of my slideshow. Now let me go back a little bit to the panelists, and I'll take a little bit more time to introduce each panelist, and then we will go through the questions for each panelist. So first, friends, it's my great pleasure to introduce the entire panel. You probably know all of them. They are very well-known figures in the aerospace community, and they're good friends of mine, and I'm really happy to have all of them here. Rob Eagles, who is a strategy and rulemaking lead at Airbus UTM, is actively engaged in the development of services, standards, and functionality for UTM and urban air mobility. He has spent more than 30 years in air traffic management and aerospace industry. And he's recognized as one of the innovators in the new entrants and aerospace operations. Our second panelist is Jennifer Richter, who is a partner at Aiken Gump, and she represents a number of clients in the AAM, US, and aviation industry at large. She has represented many technology and communication companies and investors for more than a couple of decades, and she's ranked by Chamber of Commerce and USA as the leading lawyer in telecommunications. She's been named a super lawyer for communications law multiple times. Our next panelist is Brent Ingram, who is a director. He's a senior executive service member in the United States Department of Defense, and he serves as the director of surface warfare. And he's responsible for managing and analyzing major platform and weapons capability portfolios across land, maritime, and munition tactical warfare systems. Before that, he was also serving as Director of Unmanned Systems at the Office of the Undersecretary of Defense for Acquisition and Sustainment Platform. Brent is very busy, and he's going to be in and out, but we are also very happy to have Colonel David Bennett, who works very tightly with Brent. And Colonel Bennett and I have been working on many aspects related to UTM and security, so he will be supporting us as well. The next is Lisa Ellman, who is a partner at Hogan Lovells, and she's one of the world's leading authorities in drone policy, and she is part of the most powerful woman in law World Series. So she's recognized very well, and she's currently serving as executive director and the founder of Commercial Drone Alliance. Our next speaker is Bill Stanton from FAA, who is also going to come in and out. And we are also happy to have Mr. Scott Rosenblum, who is a group manager of air traffic operations, and he focuses on airspace policy and regulations. And Bill Stanton, as most of you know, he serves as the FAA's Air Traffic Organization Senior Advisor for Policy. He influences the development of regulatory policy, rulemaking, policy procedures, and the coordination within the organization that provides procedural development and support to the NAS stakeholders. Our next speaker is Diana Cooper. She is at Hyundai. She's head of US policy at Hyundai, and her primary focus is on urban air mobility operations. And she is in charge of legislative and regulatory and policy framework for UAM and its public acceptance. So she has a broad portfolio. Before that, she worked as a general counsel at Precision Hawk, a commercial drone entity. And prior to that, she founded and led drone and robotics practice at a leading law firm. After that, we have Heidi Williams from National Business Aviation Association. She joins us from NBA as the Director of Air Traffic Services and Infrastructure. In that role, she's responsible for NBA's policy and coordination with the FAA, state and local officials, and association members relating to air traffic control, air traffic management, design, activities, next gen, all the new entrants, as well as air traffic services at the FAA Air Traffic Control Command Center. And the last panelist is Dr. Tom Prevost, who was a colleague of mine for a long time and a great friend, who is a Director of Engineering for Airspace Systems at Uber Elevate. Before that, he was at NASA for over 20 years, and he was head of Airspace Operations Lab and project lead for NASA's UTM research, a very close partner for me in the UTM journey. And Tom won numerous awards, including 2 NASA Software of the Year awards. And he earned his PhD in aerospace engineering in Munich for his thesis on autonomous and cooperative onboard flight planning. And that's what leads him to the flying cars, so to speak. So this is our great panel. I am going to now turn over to panel and have each panelist spend a few minutes, 3 minutes or so, talking about the wonderful work they are doing and what kind of areas they are focused on. And later on, after all panelists are done, we will go through some question and answers. So let's start with Rob Eagles.
Okay, thank you, PK, and good afternoon to everyone. Firstly, I'd like to say that Airbus UTM is very appreciative of being able to contribute today and be involved in the panel to discuss important issues in relating to advanced air mobility. Airbus UTM is located here in Silicon Valley at the A-Cubed Innovation Center in Sunnyvale. We also have teams in Madrid, in Europe, and Singapore. We're engaged in work around the world. In Singapore, that I just mentioned, we've got vehicles that are flying ship-to-shore operations and also testing in dense urban environments to learn and progress UAM application in general. In Europe, Airbus UTM works closely with EASA, Eurocontrol, and Cesar on Airspace. And here in the US, we're a Lance provider. We're a member of the Remote ID cohort. And also we're involved on the Airspace work track in the NASA Grand Challenge. So Airbus is a manufacturer, fixed wing and rotary. We have a primary focus within the organization on traffic management in general, from very low altitude to very high altitude and everything in between. And from Airbus UTM, we are working on, with industry, a transition to digital airspace management and the safe integration of new vehicles, including UAM. And whilst we're doing that, identifying the key challenges along with our partners in industry and addressing them, using new thinking, new ways of approaching old problems to make new operations a reality. And, thank you, PK. Back to you.
All right. Thank you, Rob. And thank you for joining us. Our next panelist is Jennifer Richter from Aiken Gum.
Hi, PK. Can you hear me okay?
Yes, thank you.
Great. Wonderful. Well, I loved how you led this whole thing off with a reflection that our airspace systems really need to be ready when our aircraft are ready. And I think, you and I talked about that at the very first UTM conference many years ago, and my concern and nervousness that the communications infrastructure, the CNS infrastructure needed to make advanced air mobility a success is on its own path and not something that people are necessarily focused on. So I'm thrilled that NASA is including this as something that's a top priority right now for us all to focus on. And very happy to be following Rob Eagles from Airbus. They've been doing some really important work in this area, both domestically and globally, and they have a very expansive view of the different kinds of communications infrastructure that could be leveraged and accessed for this purpose. So I think our big barriers here, and I know we're going to talk about this more later, but just to set the table a little bit, one of the biggest barriers with respect to CNS and advanced air mobility is the access to spectrum and identifying the right spectrum bands that can be used for all the different purposes that we need spectrum for communicating with aircraft. So the command and control, the collision avoidance, communicating with the UTM. We need systems for, ground to ground, air to air, air to ground, ground to air. There are just so many different components that are necessary. And we have to figure out what those spectrum resources are going to be. We also have to overcome some mindsets, some traditional aviation industry mindsets about what spectrum is suitable and will be permissible for these purposes, because of course, everybody wants to be able to rely on aviation spectrum and aviation systems for all of this, but I think we all recognize that there isn't enough resource available. And so we need to start thinking about and relying on some other commercial resources that may be available, including 5G systems. There's probably a role to be played for unlicensed, licensed, and aviation spectrum, all of it, but we have to figure out what those roles are going to be and how these systems are going to work together. We also really need to work with our regulators to make sure they understand what we need and that they can help get on board and make this possible so that when the aircraft is ready, the airspace systems also will be ready. And then, of course, we just need to be thinking through this whole CNS infrastructure, prototyping it, testing it, making sure that it works in urban environments and rural environments both, figuring out what those components are, what pieces of aviation industry can we leverage, what pieces of the communications industry can we leverage. So there's just a tremendous amount of work to be done. I do feel these issues are getting some visibility now, which is thrilling. And thank you for your leadership and your team for helping to put these issues on the map.
PK, you are still on mute.
Yeah, thank you, Jennifer. Our next speaker is Brent Ingram from DoD. Thank you, Anna. So if Brent, I know Brent had some scheduling aspects. If he's not here, I would request David Bennett to offer a few remarks.
Yes, PK, unfortunately, they are unable to get their audio up and working. We are still trying to troubleshoot with them. So okay. As we troubleshoot, let's go to the next panelist.
That's awesome. Okay, no worries. Thank you. So let's go to now Scott Rosenblum and Bill Stanton from FAA. So Scott, I believe you're on. Oh, Bill is on. Okay, perfect. Thank you.
I just came back, PK, so if you would give me a couple minutes to get acclimated.
Absolutely. Absolutely. So Scott, how about you? Yeah.
Sure thing, I can take this. Well, good afternoon, and PK, thanks to you and the NASA team for bringing the FAA and the Air Traffic Organization into this airspace work group. We're excited to kick it off and work collaboratively with our government and industry partners and stakeholders. UAS and new entrant integration is a high priority for the FAA. If you look at our current UAS regulatory program, it's pretty busy, up and running with a lot of major projects underway, like remote ID, operations over people, UAS flight restrictions, and that's just on the small UAS side. So we see and recognize that there's a fair amount of work to do, and we're looking forward to working collaboratively. And really, to echo one of your first slides is making sure that the airspace environment and the air traffic system is ready to go when the vehicles are. And
thank you, Scott. Bill, would you like to offer some remarks, or you want me to come back to you? Oh, you're on mute, I think.
struggling with the new environment of telework and with virtual meetings, right? So I always say whenever I do that, that I said the greatest thing, I just can't remember what it was coming back in. But I appreciate the opportunity, PK, and we are looking forward to this. Normally I would speak at these things, and I think it's a great opportunity to introduce Scott. Scott is our group manager for rulemaking and regulation, rules and policy, and I think he'll be a great addition to the team. I echo as well the need for having our airspace structure and constructs ready with our airframes. So it's a great combination, and this is a great work group kicking off on the airspace side of it. We should have that. Those two pieces should come together at the end. Otherwise, we'll struggle again, as we have in other UAS arenas, in being ready to accept these new entrants. So I think perfect, good timing, and look forward to the work.
Thank you, Bill. And Scott, we are very much looking forward to, everybody's very much looking forward to having a very close collaboration with FAA, and we are very happy that you're going to be joining the work group right from the beginning and help shape the discussion and the needs. Our next speaker is Diana Cooper from Hyundai Urban Air Mobility Policy, head of U.S. policy at Hyundai.
Good afternoon, everyone, and thank you to PK for the invitation to serve on this panel alongside many friends and industry colleagues. It's really great to be here today. As PK mentioned in my introduction, I'm a lawyer by background, now a recovering lawyer turned lobbyist and policy advocate, so most people think that's worse. I've been in the unmanned aircraft systems policy and legal space for about 7 years, initially by founding one of the first law firm practices dedicated to unmanned systems. Afterwards, I spent about 4.5 years in-house with a client called Precision Hawk, which is a commercial drone company. The early days, we were part of the UTM trials that PK was leading at NASA, really successful efforts. And we've seen so much traction on UTM over the last few years since NASA got in the game and really showed leadership. So really excited to be in the early phases of this type of work on the UAM side. In terms of my current role at Hyundai Urban Air Mobility, I'm focused on creating and shaping a forward-leaning regulatory and policy and legal framework for these types of operations across the United States, and also working with local cities and local communities and different stakeholder groups to make sure that we have public acceptance and adoption of this new emerging technology. One of the areas that I'm really excited about working at Hyundai is that we have a very human-centered approach to mobility solutions. And by that, what we mean is, future mobility solutions really need to start with the human in mind. So building solutions that people are looking for, solutions that are accessible for people with different types of mobility challenges, accessible to different socioeconomic groups, and across the board. And, if you look at traditional aviation, unfortunately, it really left a lot of communities behind. And so we want to have that opportunity from the early phases today in this new emerging sector to really, right those past wrongs and really make this technology as inclusive as possible. And so we've been leading an effort inside Hyundai that I'm excited to share today in terms of starting to reach out to different organizations that represent people with different mobility challenges or who might be hearing or seeing impaired. And so we're starting to reach out to those organizations and to other stakeholders across the industry to understand what are the needs of these groups that have not been met with traditional aviation, and how can we actually take their needs and turn them into technical requirements and feed that into the R&D teams and into the design of our products.
Thank you, Diana. And it's great to have you here with the working group. And our next speaker is Heidi Williams. She's the director at NBAA for Air Traffic Services and Infrastructure. Welcome, Heidi.
Thanks, PK, and thank you. I'm going to echo some of the sentiments of the previous panelists, and thanking you for your leadership and the NASA team. I think we've talked for many years, whether it be on UTM or UAM or AAM, lots of acronyms, right? But all that said, it's emerging technology, right? And so I look at this more from a manned perspective to some degree, having operated in the airspace. My background is a commercial pilot. I've been doing airspace policy for about 25 years. Previously for the general aviation community, now for really the business aviation sector. And a lot of what we're doing at NBAA is wanting to first and foremost embrace the technology, embrace the number of new entrants and new entrant operations into the airspace system. That being said, I think there's a lot of work around maybe taking a fresh look at airspace design. I think a lot in the manned community look at our airspace structure, look at the way we do things today as we've transitioned to PBN, and think all new entrants have to integrate into our existing system. I'm not sure if that's in fact the case. I think there are some research opportunities around what does airspace design for the future as we look at a number of new entrants. What does that look like? Can we truly integrate into our current system? Do we need to maybe rethink our current system and a new airspace type of design? You know, often we think of that lower altitude stratum where maybe UAM or UAS are going to be operating as, you know, not very densely populated airspace. You're under the Class B shelf. But in reality, as a commercial pilot, I can tell you there are lots of operations in that airspace. We are going to have to intermix VFR and IFR operations. And how do we do that safely, especially as we've looked at transitioning to this performance-based navigation system in so many of the metroplex areas, and we've created these new optimized descents and profiles, and we have new routing structures, and we spent a lot of time and effort doing that. So how do we truly integrate and not maybe lose all of that work? So to that end, NBA has been very involved. In fact, about a year ago, we stood up an emerging technologies committee to work a lot of these issues, not just with airspace integration, but with eVTOL and UAM, and what does that look like moving forward from a business development standpoint. So we stood that up about a year ago. NASA graciously offered to participate on that committee, and PK, we've really appreciated your participation there. We are also very involved in a number of rulemaking committees, specifically one that was stood up over a year ago that I just want to mention because I think it's very worthwhile, was the airspace prioritization ARC. And one of the things that we didn't do at the time that ARC was stood up is we didn't have a robust participation from the unmanned sector, from that UAM participant. We did have great participation from the commercial space. But as one of the authors of that report, that ARC report, which is not currently public, I can tell you we very much were thinking about UAM and the unmanned and UAS below, whether at 400 feet or 1,000 feet, as we looked at a prioritization schema and what makes sense moving forward. And there was a lot of thought put into that from a manned perspective, and some of the structure that we utilize through collaborative decision making and ensuring that we take into consideration new entrants, commercial space, unmanned systems, UAM. So I think there's lots of opportunity for engagement, but I love what former panelists just shared about embracing the sense of community and trying to do things different, learning from our mistakes, right? Very similar to what we're doing right now with Metroplex and the fact that we're engaging the community. That's critical. It's critical from the onset. I applaud what NASA is doing in engaging community. So we're really looking forward to participating and being part of the workshop. And I'll stop there because I think we'll get into much more. But thanks again for the opportunity.
Well, thank you, Heidi. So let's move to the next speaker, Dr. Tom Prevost. So Tom.
Yeah. Hi. So I'm really glad to be here. Thank you very much for having me. It's a pleasure to be on this panel. We were kind of joking earlier, for me going last, I would have to come up with a joke or something new. So I've been listening to everything that was said, and I'm trying to maybe see if I can provide a few other thoughts here as well. I mean, Elevate's been sort of at the core of creating this ecosystem for about 4 years now, even before I joined. And one of the reasons I joined was that it was recognized sort of from the beginning that airspace integration would be one of the key barriers here, which was unusual for somebody who's been working in airspace. It seemed to have been often an afterthought. So, of course, your initial slide was right on. Let's get the airspace system ready when the aircraft are ready. But I will also say this is not a kind of one-time thing, because I think aircraft are going to be ready in different stages with different capabilities. And our airspace systems kind of need to be reflective of this. I mean, we don't need to bite off more than we can chew right away. We may not need to build immediately an airspace systems that can accommodate all autonomous aircraft, all the capabilities we foresee for the next 20 years, but we should move into a direction where we can get to this scalable system. So I think it's important for us. I mean, we're really looking at trying to enable initial operations by in a few years, by 2023. It's awesome that we see the community here, NASA bring the community together, and we're all talking. We are all basing already about some moderately mature concept ideas, I think, that have been kicked around and have been shared. But it's also very important to focus on these stages at which we're trying to enable initial operations. So thinking about what can we do, for example, in the next 3 years, we probably can't change rules massively. We can't rely on a huge set of initial technologies, and that may not be necessary, but we do want to build something that allows us to integrate these new entrants in a different way than we operate today, that we don't go down into the same bottlenecks, and that allows us to scale moderately initially, and then maybe getting ready for the next, second generation of aircraft that might have additional capabilities and work towards those. So I'm super glad to be here. I'm glad to see NASA's leadership in this. And the one thing that I would want to point out is let's also try to really focus on the various phases. It's very easy to get caught up in the really grand scheme of things, and then not to achieve too much when it's needed.
Well, thank you, Tom. Yeah, we agree. We have to focus on both, which is access to airspace for new entrants as soon as possible, as soon as the vehicles are ready, as well as preparing for scalability. So that's a really good segue. We know that Colonel Bennett and Brent Ingram, Director at DoD, are very eager to help and participate in the work group. They're unfortunately not able to connect due to the firewall issues and provide direct voice track here, but they have offered to basically respond to any questions through the chat box, and I will be more than happy to read those to you. Do we have Anna or Cecilia? Do we have anybody new joining in, new panelist for us? Lisa Elman?
No, PK, Lisa has not joined yet.
Okay, no worries. So let's go through then the questions. I would like to also one more time introduce Dr. Tommy Daniels. So Tommy, are you on? Would you like to offer some remarks?
Well, thank you for the opportunity, PK. And I appreciate this unique opportunity here this is the beginning of something very fantastic if you think about the future of transportation in this country. It's kind of very exciting. As far as this panel, my focus is really more the aviation weather aspects, and hopefully I can help use past experience to inform this working group. With that, I'll move along. Once again, thank you very much. Looking forward to working with everybody.
Thank you, and appreciate that remark, Tommy. And what we would like to say is our Associate Administrator for Aeronautics, Mr. Bob Pierce, and Program Director for Airspace Systems, Airspace Operations and Safety Program, Akbar Sultan, they both make this big commitment for the airspace system as a shared leadership with FAA and industry. So NASA takes, we are very grateful that you acknowledge and NASA and appreciate NASA's leadership, but we do think that this is a collaborative innovation. And this is really about shared leadership with you all. This is not just one-dimensional leadership. So we appreciate an opportunity to work with our federal partners, FAA, DoD, DHS, and others, as well as industry collaborators like you. And we take this shared opportunity to lead the research development and transformation of airspace system together with you all. So thank you for being part of that. And now we are going to transition over to some questions. And let's see if we have any good questions on the conference IO first before we go to my question. So this is interesting. Well, let me just say one thing that's personal. You know, people looked at my arm and I started getting some texts and saying that is anything broken my right hand, and nothing of that sort has happened. Fortunately, just a little tingling and sensations in my fingers. So my doctor asked me to wear this splint, thinking that there may be some carpal tunnel, early signs of carpal tunnel. So it's a very minor thing, and I will recover with your goodwill very quickly, I'm sure. But let's look at the first question. So when is the next airspace meeting? So I would say, this question is somewhat, like you may say, well, that's kind of a funny question, but anytime you have a question that says, when is the next time we are going to get together again, that's a good sign of the commitment of people that are participating. So I really appreciate that question in that sense, in that spirit. And as we mentioned that I will re-show this topic of basically when our next meeting is going to be. Let's see. Okay, here is when our next upcoming events are. Again, one more time, you can take a screenshot of this, starting June 25th, 26th, and those are all, if you just remember the NARI website, nari.arc.nasa.gov, ecosystem, if that's all you need to really remember, and you'll get all the details. Here are 4 important events and meetings we have lined up for you to participate and shape the future of this ecosystem. So I will stop that and go back to the next question. I'll stop sharing now. So let me ask this question to almost everybody. What are the key barriers or urgent research development needs for urban air mobility, advanced air mobility type of operations to coexist in the national airspace system? And when we say coexist, there will be drones and urban air mobility type electric VTOL operations, as well as eVTOL and the manned aviation. So what are the big barriers you think, or the research ideas that we need to basically focus on? And before you answer that question, I would like to quickly read a statement from Colonel Bennett that he has offered from DoD. So Colonel Bennett, thank you again for your statement. And what he's saying is, first, they are very happy to be part of the panel and the work group, and they are very excited about the future, about urban air mobility. DoD is focused on 3 pillars of future of airspace. And first one is we want to continue to train. Basically, they want to continue to train to support the national defense. Second is we want to continue to support our air traffic management requirements as delegated by FAA. As you know, certain places they operate their airspace on and off. And we want to continue to protect the national resources to maintain the facilities and bases. So there's a very clean tie and connection with airspace. So that's what Colonel Bennett is offering, and they will be very happy to be part of the discussion and the work group. So thank you again, Colonel Bennett. So we will go back to the questions for the panelists. What are the key barriers, and translate that into research requirements related to the coexistence of urban air mobility operations in the NAS with drones and the manned aviation? Any panelists would like to take on? Welcome to.
PK, so from an airspace perspective, from some of the things that we look at, I don't think that we are necessarily as far behind or in the dark as some might think. I think a lot of times we describe technologies far in advance of where we are, but I think we need to recognize that there are gaps. Certainly beyond visual line of sight is still a struggle in that the technology for the aircraft to get into the air and their operating characteristics, we haven't found a match to meet the equivalent of the previously piloted aircraft, meaning the human eye in that vehicle. So the challenges, technological challenges are still present. Some of the things that I think we need to take a look at. So if we were to develop the structure of UTM, UAM, AAM, and as we described them, we need to have standards. Currently, whenever we put a 757 in close proximity to a Cessna or other aircraft, we have to take into consideration aircraft performance characteristics. Those were used in development of those standards. How do we separate these things is basically the first key in enabling greater numbers of operations and enabling these in a real-time fashion. So aircraft characteristics, performance characteristics, we need those, the maximum amount of data that we can get. We need full cooperation and sharing, partnership between NASA's research, our operational integration and planning, and wake turbulence would be another one. How is that? We talk about that quite often in piloted aircraft. How that affects our standards. Yeah, obviously we create greater distances between the larger aircraft and a smaller aircraft following, with the purpose of safety in mind. Noise impact that goes in, and I know that'll obviously be a part of the other pillar of the community engagement. But what does our community think of a drone flying 150 feet over their backyard? And then you magnify that times 1,000 for package delivery on certain route structures. We'll have those similar types of conversations. And then weather impacts. We have we can absolutely integrate UAS, but we have to consider all of the other players with this. Whenever a piloted flight comes out of a weather condition or out of a cloud, they're flying IFR. We need to make sure that our rules, our policies for the UAS operating outside of that strata, provide an opportunity for that other aircraft to remain stable and to operate in a safe fashion.
PK, you're on mute.
Oh, thank you. Thank you, Tom, for reminding me that. Thank you, Bill. Diana, would you like to address that?
Sure, absolutely. Thank you. I agree with everything that Bill said previously. And, as a couple of the panelists alluded to earlier on the session, airspace modernization, there are a lot of opportunities for us to, change the way that we're thinking about airspace design and procedures so that we can have true and full integration of all emerging technologies from, drones, counter drones, urban air mobility, cargo operations, and even vehicles we have yet to imagine that, might come around in the next couple of decades. If you look at the way that airspace was designed, it was very reactive. It was with the initial, aircraft and human pilot in mind. And so there's a lot that needs to be modified for this type of technology to make sense. So, things like the 3 nautical mile separation distance, that doesn't make sense at all for these types of, operations, especially in densely populated urban centers where you need to have, multiple vertiports in a city like LA. That all of a sudden, changes our thinking of what is controlled airspace, right? We would have the most densely populated airspaces in the world in local communities where people live, work, and play. And we might need to look at different types of separation distances based on, the equipage and the safety solutions that different, vehicles have on board. So looking at research on, dynamic separation distances, equipage, dynamic delegated corridors, and things like that I know NASA, MITRE, and others have started to talk about in recent years would be great opportunities for us to work alongside NASA and others.
All right, thank you, Diana.
Can I add a thought too?
Absolutely. Yeah, absolutely.
Yeah, I think those are all great thoughts, and I believe though we also at some point need to gain some operational experience, and so our thinking in some ways is that we're gonna start out for UAM operations, at least probably with piloted operations. Maybe under VFR flight rules, because again, for initial operations, we're probably not going to be able to establish completely new separation standards without gaining any operational experience with these vehicles as well. And I feel like we probably, again, we need to think about these things definitely and think about the longer term research, because that's also takes a lot of time, and we got to get that started. But that shouldn't block us from trying to do initial steps, try to address some of the more critical barriers to scalability that are there right away. And one of those that I certainly think is essentially the workload on the air traffic controllers that comes with the current access procedures to controlled airspace, just by having to get voice clearances into that airspace, having to get traffic call outs, things like that we can actually work on trying to minimize or eliminate as much as possible, even in the early years, to find ways of actually building up the capabilities of maybe new ways of managing traffic that is more inspired by the UTM ideas of information sharing, digital data sharing, not based on voice control, but is interoperable with the current system. And so basically build a foundation that we can then keep building on capabilities, technologies, and more complex operations over time, but we're still able to enable a decent amount of operations early on in the cities.
Okay, great, thank you. Yeah, please.
Tom's comments there about the need for this research, and I'd like to reassure the community that's watching that we are actively we have other active measures that are in place collecting that data through our PSP, Partnerships for Safety programs, the IPP, and our everyday types of operations where we are pulling together resources and efforts to enable UAS operations in these environments. So to get into some of the details, we actively partner with our these participants in IPP at Memphis. We have FedEx out there doing operations on the airport in non-movement areas, and as they want to expand their operations, they are again partnering with the FAA to share that data, to develop exactly the types of scenarios that Tom and Diana were just elaborating on. So I think that exactly we concur with the group. We are actively now trying to find solutions to those via the very research and integration methods that were described there.
Well, thank you, Bill. Jennifer, would you like to add some thoughts?
Yeah, I would. So as I indicated earlier, we really don't have a reference communications architecture for all of this, for all of the CNS functions that are so necessary to make this dream of advanced air mobility real. And it really does start with the spectrum resource. And we right now don't have complete alignment in our regulators and with Congress about what those spectrum resources ought to be and how they can be used. So a lot of the people on this webinar are probably familiar with the Section 374 report that Congress requested. to try to get the FAA, the FCC, and NTIA to come together about the 5030 to 5091 spectrum, the 960 to 1164, even commercial wireless resources, 5G, and how all these different components can be utilized. What is their vision for the best use of these spectrum resources in a communications architecture for advanced air mobility? We're still waiting on that report out of the FCC and the FAA to Congress. That's really just a vision. That's not actual requirements. So we do have to get down to what are the actual requirements. And there are many pieces to this. So beyond the spectrum that we can utilize, and that's going to take rulemakings at the FCC with respect to some of it, and probably some standard setting for the FAA. We also just have some testing and prototyping that's really necessary to figure all of this out. What are the communications requirements for each aircraft and for a scalable ground-based system to support all of that? What is the data that needs to be exchanged among all of the stakeholders? And we have to try to predict the volumes and then what the system can support and what infrastructure do we need, wireless, fiber, storage, edge computing, cloud computing, all of it. So much that needs to be done there. We have to identify the kinds of links that are necessary. As I said earlier, air to ground, ground to air, ground to ground. We've got to develop this baseline CNS system and architecture for all of this, and we've got to prototype it. So many different things to think about, and I could go further if we want to talk about specific research, but these activities are so essential and really do need to begin in a public way. I think a lot of it is being done privately. I think a lot of the innovators in this space have been studying how they can use different communications resources, whether they're aviation or from the commercial wireless spectrum, in order to support their operations privately. But now a lot of this needs to be tested publicly, and we need to bring our regulators into the fold on it so that they can understand how these different systems function, how they might function together to perform different kinds of support for advanced air mobility. That data is really necessary for our regulators, because without it, they can't help us advance the regulatory structure that we really need around all this.
Yeah, so thank you, Jennifer. Rob, you want to go first? And Heidi, would you like to also add some comments? Or Rob, go ahead first, and then, yeah.
Thanks, PK. I'm just going to add some high-level comments. I think taking the discussion out to a little bit back to a higher level, what I think is critical is with any new operations, and in particular the more advanced type, is understanding, quantifying, and managing the new risk which is going to be introduced to ensure we don't have a negative impact on the NAS or NAS users. In particular, how we manage off-nominal situations and really understanding what the variables are that we have to consider in the future environment. So we're somewhat still in a very conceptual theory mode, and I think the faster we can get into learning from practical operations, the better. And also, what are we going to be able to do with respect to autonomous operations AI? What are we going to be allowed to do, and the path for regulation and certification? So some big questions in there to at the higher level, which directly translate in what we will be able to do and demonstrate we can do safely.
Yeah, thank you. Heidi, would you like to add some thoughts?
Yeah, I think a lot has already been shared, and I agree with what all of the other panelists have offered. Just to reference some previous work, and it sounded like Jennifer was almost reading an ARC report that we put together on UAS and controlled airspace verbatim. She had a lot of the topics that were covered in that report, but that was very focused on Class A airspace, and we're not talking about Class A. We really, there's a big gap in what that ARC did and the report that came out of that, because we were told focus on Class A airspace. We now need to really focus on this lower altitude stratum and figuring out what CNS requirements and standards need to be developed to operate in that airspace, but also for IFR procedures? Do they look the same as manned procedures do today? I think what the UAS community told us as we looked at that just briefly in that arc was that they probably look similar. We might not need a whole new type of procedure, but they are going to differ somewhat because of the autonomous operations that we largely don't do in manned operations. So I think there is that gap right now in that lower altitude stratum, but maybe building on some of the work from that UAS and controlled airspace arc.
Well, thank you, Heidi. All right, let's go to the next question. I'll take question from the audience here. The question is for passenger carrying urban air mobility aircraft. Is the expectation that FAA's air traffic management manages the airspace aspects? And so that question is open for anybody who wants to offer comments. I don't know, Bill or Scott, you want to go first, but you certainly have some say into that, you know.
So if I got the question right, PK, for package delivery, how will air traffic will it be managed in the same means as we do today? I'm sorry, I didn't.
It's a passenger carrying urban air mobility vehicle. So it's basically people carrying eVTOLs is the expectation. The FAA air traffic management will manage the airspace for eVTOL passenger carrying vehicles.
So in the past, similar to say low-level helicopter routes, I would see that initially as where we start piloted vehicles with definitely testing equipment on board managed via an automated system. And they would be managed very similarly to the way that we do an air taxi type operation, low-level helicopter delivery, passenger delivery type operations today. In the future, dependent upon the vehicle and what standards would have been established, those separation standards, how it interacts with other UAS, how it interact with manned flight flying in the same architecture, we see this system moving from that piloted vehicle operating under circumstances that we have today into a system that absorbs new standards into a more autonomous type scenario where we do focus on what would be an off-nominal type situation. Something to consider whenever you fly into an airport or into a via helicopter or winged aircraft, you know, the air traffic controller up in the tower would scan the runway and we look for certain things and then give you the clearance to land. Even though these systems become more automated and then eventually autonomous, we still need to ensure the safety of those that are using the system and those that would be affected by the creation of an off-nominal situation by not monitoring those types of things. So if we had a passenger carrying UAS that was landing, we would have to have some sort of assurances that there's been a look out there at that vertipad. Often we have wildlife that would be that would get into the airport environments, despite all of the efforts of our airport authorities and others that try to mitigate that. But safety assurances, there are going to be some ties tomorrow to the way that we do things today. The best parts of is what I would hope for. So we're going to have some sort of a combination of human interaction for those off-nominal scenarios and a set of criteria, a set of requirements that build the architecture of a UTM UAM system.
Well, thank you, Bill. And I know Lisa has joined us, so we will come to you with some questions pretty soon. As soon as this current question is over, I don't know if you are ready to chime into this current question or wait till you kind of hear what's going on. So I'll give you a little bit of break so you can catch your breath here, Lisa, and we'll catch up with you in the next round. So anybody, thank you. Anybody else wants to comment on the current question, which is the expectation that the ATM will be managed, FAA will manage the ATM aspects of airspace for passenger carrying urban air mobility vehicles. Tom, I see you would like to offer some thoughts.
Yeah, if I may, as well. I think definitely we all hopefully by and large agree that the FAA is the regulatory authority for all airspace, and is essentially in charge of how that airspace is managed. But I also think along the lines of what Bill was saying, with sort of the approach that was taken in UTM to try to give some more of a distributed network for additional services that are being provided. I think it would be good to establish a concept essentially that is built around this, where there's actually we can leverage the industry's capability to build some of these services that might be related to like sequencing aircraft onto those routes, conformance monitoring, providing like the digital infrastructure that can interoperate with the FAA system, so that we don't necessarily put the full burden on the FAA to build an expanded centralized ATM system, but follow kind of these thoughts in there, and but again, certainly assume that the FAA regulates all airspace.
Okay, great. Thank you, Tom. Anybody else who wants to offer comments? I know, Rob, you have your hand raised, but I'm not sure that's from the previous question or this one. Okay. All right. Anybody else? Otherwise, we can move on to the next question. All right. So great. Let's welcome Lisa Ellman. Again, as I introduced Lisa, she is founder and executive director of Commercial Drone Alliance, and very, very active member. So Lisa, I would like to give you a couple of minutes to offer your comments, remarks about the airspace integration for urban air mobility, and what your thoughts are and what your current priorities that you have seen from your industry stakeholders.
Yeah, absolutely.
Welcome.
Yeah, can you hear me okay, first of all?
Yes.
Yeah, okay, great. Great to be with you all. Sorry I'm a few minutes late. I was wrapping up another webinar on COVID response and UAS response to COVID. So apologies for being a few minutes late. And thank you for having me. As PK said, so I actually wear two hats. I run the global UAS practice group at Hogan Lovells Law Firm, as well as founded and now serve as executive director of the Commercial Drone Alliance. And the Commercial Drone Alliance is what it sounds like, commercial drones, but it's really size agnostic. So we're everything from small drones to large drones and UAM and AAM and everything in between. So, you know, our focus is on enabling this amazing technology and working very closely with relevant federal agency stakeholders, including, of course, NASA and the FAA and the security agencies and others. I think, you know, over the last several years, there's been a number of lessons learned from the small UAS space that I think can be really applied and again, you know, taking advantage of the fact that we learned these lessons with small UAS and hopefully won't have to learn them again with integration of UAM and AAM. You know, right now in the era of COVID-19, I think with a lot of research and development efforts that have been put on hold in the industry, we're really focused on working with the federal government to try to enable some of this research and development, put Americans back to work, help support the industry through doing airspace risk analysis, development of physical and digital infrastructure, and finding ways to really move the industry forward over, you know, the next year or so and beyond. There's a lot that we can do now to support the industry moving forward, and so I'm really excited to join you all today.
PK, you're on mute.
Thank you, Cecilia. Thank you, Lisa, for joining. And I will go to the next question here from the audience. To meet the airspace is ready when the aircraft is ready mantra, what specifically have been identified to make this happen on this path? Will there be an aviation rulemaking committee? Will there be new flight rules? What are the possible steps in an organized fashion that we could take. And, of course, so I'll stop. This is the real question. And, I'll just add a little flavor here of my own, which is that the working group that we are kickstarting today is the first step towards that in terms of identifying the gaps and where we need any rules, where we need research, what's ready, what's not, where we need procedures and such. So that's kind of my view of thinking, is that this is the beginning of that. So anybody who would like to take that question, as to the question again is, to meet the airspace is ready when the aircraft is ready mantra, what kind of things need to happen in terms of rulemaking committees and new flight rules or anything else? What are the thoughts on how do we actually go about making it happen? In a way, what would be building blocks to get to that kind of a construct?
Sure, I'll go first. I think there's a lot that needs to come together, over the next decade before we truly see these operations pervasive in the airspace. Both on the regulatory side with the FAA, there's a lot of work that needs to be done on certification. So of course we've got Part 23 and aspects of Part 21 that are currently being applied to start to get these vehicles operating. But there's a lot we still need to learn about the new components of these technologies, like distributed electric propulsion is not that well understood yet. And so a lot of work still needs to be done there. We're going to have initial pilots on board these vehicles, and so we need to work together to figure out, what are the pilot testing and training requirements? How do we develop the workforce for these pilots that will eventually be replaced with autonomy, and find new opportunities for them to be employed within the workforce afterwards? There's a lot of work that needs to be done in terms of standards and regulations for the infrastructure as well. So really understanding, will vertiports be regulated more like heliports, where there's a design standard that you have to meet, or will they be more like traditional airports that are certificated and fully regulated by the FAA? So a lot needs to be done in terms of airspace, operators, pilots, as well as the infrastructure.
Thank you, Diana. Yes. Sorry, go ahead.
As a follow-on to that, certainly our airspace rulemaking has to catch up. We're actively, taking a look at some of previous airspace ARC recommendations, current rulemaking for beyond visual line of sight. Is there a new designator of airspace? Those types of questions will have to be answered. Some of them we're answering today. And to the question of new procedures and new policy, we are actively taking a look at how we do things differently. The early phases, I can't remember if it was Diana who pointed that out or someone else, but where it was more in line with segregating and telling UAS that they must be separate from and must give way to. So there's new considerations to how do we fully integrate. How do we build our airspace structure and rulemaking and operational modeling around a concept that is more akin to shared airspace access? So I think that this type of activity, this airspace working group that NASA is putting together and leading, will give us those recommendations from experienced folks, as we do have on this panel today. So consideration for those things, we're actively looking at that, and that work will be fed from this type of an activity. Scott, I'd like to, if I could, ask Scott any thoughts on that, because again, that's definitely in his wheelhouse, the rules and regulatory process.
Yeah, I can really quickly add and kind of piggyback on what PK started off with, is that we see this work group as an opportunity to collaborate and engage with different partners to really identify what the gaps are, and then help the FAA plan and execute any rulemaking activities that are required to bring us up to where we need to be to enable the operation. Identify what policy changes, what new procedures. A lot of talk on communication and CNS infrastructure. So it's really, I think it's going to be very helpful as we kind of work through all this together to help identify those gaps and allow us to, plan appropriately and apply resources appropriately to get us where we need to be.
Great. So I will go to Heidi. Thank you, Scott. Heidi, you go, and then I think Lisa is the next after that. So thank you, Heidi. Go for it.
Sure. So Scott and team already kind of mentioned what they're reviewing in terms of ARC reports, but one of the things we've talked a lot about procedures and policy. The other thing that was identified early on, or that we've talked about over the last few years, are automation tools. So not just from the aircraft standpoint, but from our system standpoint. So NAS automation, do we need changes to our current ERAM, to some of the other systems that the FAA manages, or UTM, for instance? There's also automation tools on the controller side that I think we identified that would certainly enable integration in a better way. So none of those things happen quickly, right? We know that even looking at updates and in cycles for something like ERAM, we're talking 5 to 7 years out at least, if we identify it today and get it in the update cycle. So those are some of the things that I think we need to be talking about now, what tools are needed from an automation standpoint, even with the interaction between UTM and ATM, to make sure that those are enabling capabilities.
Great, thank you. Heidi, Lisa, would you like to go next?
Yeah, sure. So, hey everyone, I think in addition to all of the excellent comments we've heard so far, obviously the FAA and DOT have a critical role to play here. I do think in terms of the lessons learned from the small UAS space, one thing that will be critical for our community moving forward is to be engaging with the broader interagency as well. There's obviously many other agencies. I know Tim Bennett from DHS was going to join this group and couldn't today, but the national security agencies also have their own equities. And so just making sure that we're engaging all of the relevant stakeholders on the front end so that there isn't a years-long delay like we've seen in the small UAS space with remote identification and counter-drone issues. So that's just something that I would want us to keep on our radar as well, in addition to the very important aviation issues that need to be considered.
Yeah, thank you, Lisa. And we also have a comment from Brendan Gurm from DoD, and he basically re-emphasizes the facts that Colonel Bennett made, and he said that we are a very strong supporter of the 3 pillars for the DoD, and DoD supports the innovation and commercial industry development. They look forward to supporting partnerships that will safely and securely identify, track, and warn manned and unmanned aircraft. So they are taking their mission very seriously. At the same time, they are here to help us enable the new missions that are out there. So thank you, Brent, for your comments. Let's go to the next question. So I'm going to go to the next question now. This question is kind of similar to previous, but let's see. Okay, this is a good question. Let's look at how will the collision avoidance between the drones and the manned aircraft, and in this case, I would also expand the drones and to urban air mobility eVTOLs. So let's just look at the collision avoidance for drones, eVTOLs, and the current manned aviation be addressed. Is ADS-B the choice FAA will look for, or is UTM integration and ATM UTM integration possible solution to address the tactical separation? So anybody would like to offer some comments on the tactical separation and making sure that safety is guaranteed across all users in the low altitude, particularly the drones, the UAM, eVTOLs, and the manned aviation. And a question was related to whether ADS-B is a choice or something else would be the part that we consider.
Hey, PK, I'll jump in on that if that's okay.
Thank you. Yeah, sure, please.
Yeah, so I'm sure ATM sorry, the UTM system obviously will have a major role to play here, and ADSB will also have a role to play here. I think there's no doubt about that. But I do think that we need more than that. This new system can't really rely on ADSB for separation of all these new aircraft that will be in the air. FAA tells us that would be way too many interrogations in the system, and it would crash the system. It essentially wouldn't work for manned aviation, and so we can't have that. So we need new resources on the collision avoidance front. A number of the interest groups here, NBAA included, have filed with the FCC about some spectrum that's available for collision avoidance, principally for ground-based vehicles, the 5.9 gigahertz spectrum. But that spectrum also can be used for airborne collision avoidance. The FCC doesn't have any rules that allow it, but the prior rulemakings talked about the ability to use that spectrum for airborne. There's so much work that would need to be done on that to the extent that were possible. But the number one most important thing is to weigh in with the FCC, the Department of Transportation, the FAA, about the importance of finding more spectrum for collision avoidance that can be broadly used for everyone around the industry. And that this is something that we all need to be working on together and making sure our regulators understand the importance of this, because right now the FCC is looking to open that spectrum for basically Wi-Fi uses. So these are the kinds of things, these are the kinds of gaps that this group really does need to be working on.
Interesting. Thank you. Anybody else would like to add comments on that? The question again is related to collision avoidance and separation management across drones, urban air mobility, eVTOLs, and manned aviation. Go ahead, Tom. Sorry.
Yeah. Well, my thought is I think these are, again, there's probably different solutions for the different groups of aircraft and problems. In some sense, I think introducing eVTOLs and UAMs with pilots is a little bit of a simpler problem than the UAS beyond line of sight flying in the middle of the other aircraft. I think we can rely a lot on structure, and again, like Bill was mentioning initially, by initial sort of segregation or designation of certain helicopter routes, airspace routes that are well known to the controllers and everything, and relying on kind of pilots' VFR operations, we may not need initially full detect and avoid automation on the aircraft that covers everything. So I think there is some element where we can still develop and learn some more, and we shouldn't be entirely blocked by this. And we should look at what is the right technology. A UTM type system can certainly help coordinate these operations quite a bit and keep monitoring that the aircraft are highly predictable, that you know where they're going to be flying initially, and thereby kind of separate out some of these problems through structure already.
Yeah. Thank you, Tom. And Brent has offered some comments, and I will get to you, Bill, in a second. So Brent mentions from DoD that the national airspace system will become very complex as a result of this new entrants, and through building a cyber secure and resilient airspace management systems with performance-based controls will allow for safe separation and operation of manned and unmanned platforms in the same airspace. So the point is valid, Brent, that you are suggesting that we also look into the security and resiliency of management when we consider the separation. Thank you for that comment. And we will go to Bill.
A minute to figure that the mute, unmute, and camera out. But I think what we're talking about early on, and we're using some of these methods today. What is strategic separation versus tactical separation, and I think that is just basically going to set up our early framework. Someone had mentioned ADSB, and I believe Heidi answered that question are some concerns about and limitations as to what that system can accommodate. Early on, a lot of this separation will be strategic. We talk about airspace being ready with the aircraft, and in the airspace today, if we talk about the systems that are operating in the air today, some of the aircraft we have do not have the capability to do what we would expect in Class G uncontrolled airspace versus a very congested Class B airspace. So what we need to do to move forward is make sure that the aircraft that are being developed and the pilot qualifications match the environment in which they are operating in. I think that's going to be key. I think capturing the data as we go forward, we're going to get more and more information from these strategic controls, and that'll help us develop the criteria that will feed into the systems for the tactical measures tomorrow. So we're going to move from a piloted aircraft or pilot on board a UAS or a non-piloted aircraft, for that takeover scenario. We'll move from that to an automated and autonomous systems. I think that UTM will certainly bridge those gaps. Some of the other conversation from the other panelists, we're going to have to take a look at our existing systems. We're going to have to modify. We will have to evolve. We'll go from those systems where we're reading those clearances into a Class Bravo airspace. Those things will be set into criteria, as the ANSP will be responsible to ensure the safety of everyone operating in the NAS. But it doesn't necessarily mean that there has to be a human voice attached to that. There may be a system monitor, if you will. I don't know for sure if that will be the case, but we have to leave the door open for new options. And I think that this group will pull that together very well. So we move from a piloted aircraft into a more automated system, autonomous, and then how do I keep calling this the handshake? How do we get that handshake between UTM and ATM? These are the things that this group is going to figure out.
Great, and I'll just offer one remark for my own personal opinion. Is if the aircraft is interested in operating in the UTM environment, that it's compatible with the UTM capabilities that are required to meet that performance, digital cooperative intent sharing and so on and so forth. And if the same aircraft wants to also operate in the ATM environment as it exists today in the very near term, then it will also be capable of interacting through the ATM environment, much like other manned aviation. So in other words, one possibility that if aircraft or vehicle wants to operate in both environments, then there could be a dual capable. That's just an option to consider as we look at the research and alternatives so that we can reduce the friction in trying to get access as quickly as possible. So that was just my personal thought on UTM, AAM, ATM integration. But anybody else wants to offer any thoughts? The question is, how will UAM, AAM be integrated with UTM? If there are any folks who want to take that on, again, the question is, how will UAM, AAM be integrated with UTM?
I think it's that handshake, PK. I think we're going to have a system that is being developed by requirements. We will take the data that we're getting today via strategic separation. We'll develop those into a more dynamic tactical situation set of requirements. That will set the framework for UTM. How they interact as you move closer into an air taxi type service. Someone wants picked up 10, 15 miles from a major metropolitan airport, JFK, Newark, something like that, Dallas, Fort Worth. They want to move 10, 15, 20 miles away, get quickly into the airport to meet their next international flight. There's going to have to be some sort of interaction there. How will that look? Again, we'll have to consider that there may be, there's going to have to be definitely some monitoring. There may be some interjection where instructions have to be given in emergency type situations. There is the possibility of wildlife getting onto one of these vertiports. We'll have to have some sort of interjection there to resequence and ensure the safety of those passengers being delivered and those that are operating on the ground that could have been affected in a catastrophic type situation. So to avoid those things, I think the interaction, that handshake, if you will, is going to be initially, it'll look similar to today's operation, but what we'll do is build on the criteria, the best practices of today. We'll put those into a very detailed data set, a detailed criteria, and then you can automate things from that. Still muted. Okay.
Thank you for reminding me that. Brent has also offered a comment that it would be the performance-based controls, the construct of performance-based controls that would need to be established for each platform and that each type of airspace with documented performance standards. In other words, research that's supporting the standards that will be able to operate in a more dynamic environment. So his main point there basically is that performance-based criteria and need to be established so that these will remain interoperable and coexist with each other. Okay, anybody else wants to take that same question? I think I had seen Lisa's hand was up, but I don't know I could see that anymore. Lisa, you wanted to take the question of the UAM, AAM integration with UTM? Rob Eagles. Okay, Rob Eagles has his hands up. Okay, Rob, please go ahead.
Yeah, thanks, PK. Just to offer a few thoughts on that, how is it going to happen, the integration? I think it's going to be gradual. I think it needs to be steps going forward. The complexities are huge. They may be easy to not appreciate interfacing into some of the legacy ATM systems around the world. So, to start with the interfaces and ensure there's effective and secure information exchange. The next step, situational awareness, and then joint airspace management, leading through a path to joint decision making and control. So a stepped approach, looking at how UTM and ATM may converge, and also an opportunity to look at testing some of the technologies that are being proposed in the UTM UAN arena, and see if they're fit for purpose for those original arenas, and then see if there's any synergies and an ability to support the wider traffic management as well. So a lot of work, a lot of complexity, a lot of technical requirements to be reviewed and assessed, especially considering some of the candidate technologies that are being presented for different functions. But just a staged approach based on situational awareness, leading into management, leading into joint decisions and control.
But thank you, Rob. Anybody else wants to take that? Otherwise, we go to the next question. So the next question actually says FAA bill, but I think we can ask this question, generalize it a little bit, and ask everybody, all the panelists, what future role do urban governments, so I will generalize it to say what role local governments may have in the urban air mobility, advanced air mobility, as we look at moving forward. Go ahead, Diana, please.
Sure. So traditionally, the FAA regulates the airspace, and state and local governments regulate takeoff and landing through their zoning powers. And so the primary role, for local governments in terms of urban air mobility regulations and laws is on takeoff and landing. So identifying locations for vertiports. Of course, some cities are taking a more active role and, are participating with NASA and with FAA on other discussions. Some may want to, potentially have their own USS that hopefully will operate under the parameters of the FAA requirements and rulemaking and certification. What we would like to see, is the FAA maintain rulemaking authority over the airspace, but have the ability for local communities to weigh in and discuss, their concerns and on noise and public acceptance and other issues, because this technology is closer to home for a lot of people than traditional aviation. And so, there is definitely a strong interest and a need for local communities to be engaged. But at the same time, we don't want to see a patchwork of laws and regulations across the country with different equipage or noise requirements. We really want to see as much uniformity in the system as possible.
Okay, thank you, Diana. Sorry, go ahead, Heidi, and then we'll go to Bill. You're on mute, Heidi.
Thanks. Diana, you stated that perfectly. We echo your sentiments. I think the FAA maintaining sovereignty over the airspace and regulatory oversight of the airspace, it makes perfect sense. I think there is certainly a role for local communities and local government from a zoning perspective, from the vertiport side of the house. But I also echo, Diana, your sentiments about the outreach and community engagement, because as we found with other things like Metroplex redesign, that's a critical component. It's critical if we're going to do this right from the start. So communities have to be engaged, they have to have a seat at the table, and they have to be able to collaborate with us from day one.
Thank you, Heidi. Bill, and then Scott.
I'm going to let Scott answer this one. I think he's got some good remarks to add here.
All right, awesome. Go for it, Scott.
Yeah, it's great to see our work group is already gelling on this. We absolutely agree that the statutory authority to manage the airspace, and at this time we have no plan to give that up. We do not want to see a balkanization, if you will, of the authorities to manage the airspace over states or local local entities. I think we've done a lot in terms of enhancing community engagement that we can take lessons learned from. What we've seen in what we've done with Metroplex in certain areas to ensure that we're engaging with the community early and we're being transparent in what we're doing. And I think that's going to go a long way to help with consumer reliance on when a new entrant like the AAM systems. So.
Well, thank you, Scott, for your comments. Let's see, Jennifer, would you like to add? Okay, sure.
Yeah, so I think this is really an area where companies involved in this group and the associations as well should be thinking about interfacing with communities. And I thought everybody here had great comments on that. It's so important to impress on them the importance of having smart infrastructure that can support all of these innovations in the air. And so they do have a role to play with respect to permitting robust wireless and permitting fiber optics and all of the sensor technology and all of these sort of physical infrastructure components that really are necessary in the cities in order to support these innovations in the air. So it's not too early to start those conversations as well.
Okay, thank you. All right, anybody else has any thoughts? Otherwise, we move to the next question here.
PK.
Yeah, please go ahead. Lisa, you wanted to add? Yeah, okay, go ahead.
So I 100% agree with everything that's been said by Diana and Jennifer and others. I would also just add, and it's incredibly important to do community engagement. And of course, this is one of the success stories of the integration pilot program for UAS in terms of interacting with communities. And I think that that's critical. I would also just mention, of course, we need to be watching state and local activity very carefully because we don't want a patchwork quilt. I would also just mention that some of the trade groups are working together, including the Commercial Drone Alliance, to track some of other efforts that could potentially craft laws or, in this case, It's a restatement of property that could actually very much impact what we envision airspace access to look like. And so that's something else that we're going to want to keep close tabs on and be engaged with that process as well. In addition to any kind of Uniform Law Commission and other nationwide state efforts or more legal efforts that are in, kind of related areas that we're going to need to watch very carefully and participate in.
Thank you, Lisa. Okay, all right. So thank you for everybody's comments on that question. We can move to the next question. The next question has to do with international companies or governments. So are there any international companies or governments that can provide examples of how fully autonomous system architecture might be built? I have my own thoughts, but I will right now allow panelists to provide their views, whether there are lessons learned from outside the US that we could be looking at fully autonomous systems and architectures. I kind of feel that we are at the forefront, but we are always willing to learn from if there are things outside, but I will look forward to panelists' comments on that.
I think what I would add there is that one thing that we noticed from international activity is their willingness to just jump in, both feet in. I think that within our NASA architecture, we have the benefit of several decades of understanding and of our research and after action activity when we've had incidents that fuels our efforts to lead in the safety part of the conversation. But there are those outside, I think, that influence our desire to move forward by their energy that they bring into UAS, their efforts to, like I said, they jump right in without fear.
Yeah, and my take is always this. I'm going to show you a quick slide on what I think is the right thing to do is this. Let's see. Here is what my mantra is, embracing innovation while maintaining the safety of operations. So, of course, we want to be innovative. We want to enhance the businesses and allow value from the airspace operations to as much as possible. But at the same time, we maintain the safety of operations. So that's sort of what I personally feel about these things. But I will I'll get back to the panelists. What they think. Any other panelists would like to offer comments on that? Go ahead, Diana. Yeah.
Sure. I think the question was about, international perspectives and global companies and, autonomous systems. And, there's certainly really cool technologies being developed in many countries around the world. A lot of great research efforts at academic institutions, in the US and abroad. Nobody's really there yet, and we're not going to get to autonomous systems by flipping a switch. It's really about building one layer after another, getting to that ultimate end game. And I think the U.S. has really led the way in terms of UTM, ConOps development and the research within NASA, and that concept has really been adopted by many countries around the world. So I would like to highlight, that the U.S. has really been, at the forefront with NASA and PK's leadership on, arguably the most critical aspect of, future autonomous systems is the UTM construct that was developed here.
Thank you, Diana. And Tom, you wanted to add?
Yeah, I mean, I can basically echo what other folks have said. I think, and I'm certainly not aware of everything that's out there in the world, but I think we have autonomous systems operating in probably more constrained environments. I mean, there are autonomous train systems at airports and autonomous train systems in some cities, but typically you have the rails, you have a limited set of degrees of freedom that you need to manage with these systems. And I don't think anybody has actually kind of cracked the code on something as complex as the airspace system and moving that to autonomy. And going back to what Rob had said earlier, I think this kind of a phased approach of starting out with building the kind of the common infrastructure, situation awareness type things, learning, and then getting into more and more complex types of technologies that can ultimately lead to autonomous operations would be the right approach in such a kind of safety critical environment that we're in.
Yeah, and I personally have two teenage kids, so I have learned to respect the autonomous systems and integrate them in the daily lives for sure. Okay, next question. Will there be a reliance on non-GPS solutions? So will urban air mobility, advanced air mobility will have a backup for source for navigation? So this question has to do with, again, GPS and a backup to GPS. This is particularly important as we start to operate in the urban airspace. There are places where GPS degrades, or the signals are weak, or multi signals, all kinds of interesting challenges we have seen, particularly with drone tests. But anyway, any comments on the GPS, alternatives to GPS? Well, it sounds like a good topic to be considered in the work group, since we're not quite offering any comments at this point. So we will take that and use it in the parking lot for the work group. Oh, Heidi, did you wanted to offer comments? You're on mute.
I need to learn to hit both buttons at the same time. The only thing I was going to offer there is, right now, a lot of the industry, and I'm sure a number of the folks on this panel are in the midst of talking about legato and the impacts of even that plan on GPS reliability moving forward. So I would say it's definitely a topic for the panel. It's something that we need to consider and work through as part of the workshop, because I think we need to be talking about GPS backup options, especially in light of Jennifer's comments about the use of spectrum and the impacts. So I think it'll be a good future topic.
Yeah, good. And then I will take this question that's targeted towards me, and I would be happy to address that. There is no question that is here not to be discussed. So I'm happy to address that. There's a question here that says, you keep saying, which is me, I keep saying this is a collaborative, but when can the audience participate? This is deeply disrespecting and arrogant of NASA to treat your audience, who are technically qualified and an active part of the ecosystem. So first of all, thank you for the question. I appreciate the question. And maybe we didn't make it clear that the goal of the working group, this is a kickoff of the working group. This is not the working group audience participatory completely yet process started, but we started that today through starting with the working group kickoff. As the work group starts to meet, which we showed you some topics as we are going to meet, and subsequently there will be monthly working group meetings where you will be participating as an active collaborator and not not just listening to what this is. But the idea was today's panel was to kick off the working group, as we were trying to say in the beginning stages, that this is a kickoff meeting. This is not where everybody participate in everything. However, we have offered an option to put together the questions through this conference IO. Moving forward in the working group, there will be, as you had imagined, that we were going to kick this off in March in person in DC, where people would have got together and sat together and discussed in the working group. We have a similar setup that we executed in UTM. We had a number of working groups and everybody participated and collaborated to develop ideas and the research issues and solution strategies and even solutions. So that's how it will be done. We certainly do not mean any disrespect or offer any lesser reverence to our audience who are very eager to participate and technically qualified, and we are very grateful for your participation. So as the working groups get kicked off, you will have participatory things. As I mentioned in the chart, one of the charts, there will be single work group, everybody participates and you get to contribute. And today's event it's a more of a kickoff event. As much as I would have liked to have every one of you be part of the panel, that was physically impossible from the IT infrastructure. So this is the reason why we chose the format, is to start with the panel kickoff and then have this conference IO that allows you to offer questions. But then the kickoff, after the kickoff, we will have working group meetings where we will all roll up the sleeves and be part of basically discussions, and you will be able to collaborate and offer your views and ideas. And as I mentioned before, our end product is book of requirements and guidance based on the research. So we do not mean any disrespect, and I appreciate the question and the intent of the question to try to be inclusive. And we of course, we are always open for better suggestions to do how to do that better. We have done similar things in the past, but we are also happy to accept any suggestions you may have to do this in a better way, that you may feel more included as part of it. But we look forward to your personal contributions and engagement through the work groups as the work groups get started and meet focused on these topics. We will be basically offering you the opportunities to contribute. So thank you again for that question, and I appreciate your sentiment there. Let me ask you, okay, so is there anybody else who wanted to say, but I was going to, now we got 8 minutes left. And so that question was actually right segue into going into what I wanted to ask as the last question of the day, which is what would be a good list of issues from just top of your head, what you have heard today, what you have been thinking, what you have been grappling with. What are the list of questions or the topics that we should be thinking about as part of the work group? And this also goes to everybody that's listening right now on YouTube. You may also offer these set of questions and topics that we should be considered. Our mission manager, Davis Hackenberg, is very keen on making sure that we have this participatory structure of all the working groups of different types of aircraft and airspace and infrastructure, where everyone has an opportunity to offer comments as well as contributions. So if I may ask each one of the panelists a question that reflects what are your views of, let's just say, top 3 or top 2 topics that we should start to consider in the work group. And that this is the same question all the audience that are watching right now should thinking about, and offer and send emails and provide their commentary on the work group priorities and topics that we should be considering. So who would like to go first to say which work group topics we should be thinking about? Yeah, go ahead, Scott.
I think kind of two big things that stick out for me is what we call the handshake between the UTM system and the ATM system. The touch points from automation and technology, infrastructure, policy and procedures. That's a big nut to crack, I see there. And also how manned aircraft are going to be expected to interact with AAM aircraft kind of as we move from a piloted AAM type eVTOL aircraft into optionally autonomous or fully autonomous. I see those two big nuts we got to crack.
Yeah, you pick PK. You're on mute.
No, so go ahead. Thank you, Scott. Go ahead, Tom. Jennifer gave you right of the way, seems like.
Okay, sorry. Following up on this, I think in the near term, to me, again, very, very concretely and related to what Scott was saying, how can we enable kind of initially scalable UAM operations without requiring radio communication with the air traffic controllers is like a very first step. I think then for a midterm question that I think is very interesting, what would be the flight rules required to enable low visibility or kind of operations under instrument meteorological conditions without utilizing the current IFR standards that would go very much in the way of scalability. So do we need a new flight rule for that environment? What are the separation standards, those types of things? And then I think for the far term, again, what does it take to enable fully autonomous, so non-piloted operations?
Thank you, Tom. And Jennifer.
Hi.
And thank you for being patient. Yeah, so go ahead.
Of course. Obviously, we need to come up with what are all of the components of this communications architecture that we need to support AAM. But we also really do need to focus on assessing the capabilities of commercial wireless networks and 5G to support these innovations. I think that everybody has the notion that that's possible. I know that it's been tested privately, as I said earlier, but we do need to have some public testing in order to validate this, in order to make sure that our regulators have that information. We also need to assess the interoperability and what kind of systems we might put in place for when we can use the commercial wireless networks or satellite networks versus using aviation resources, and how are all of these pieces going to come together. So the study and evaluation of these commercial resources as part of this overall plan is really important.
Thank you, Jennifer. How about next? Who else wants to go? Oh, Diana, go ahead. Then Rob.
Sure. I agree with the former panelists on the, airspace integration, topics to be discussed under the working groups, as well as the vehicle issues. I'll add my earlier point on, on the community side of things. We would love to see a working group work on accessibility issues. We don't see this as a matter of, competitive advantage between, our company and other competitors in the space. We would really like to see, all vehicles being developed be truly accessible to communities, and same with the vertiports and the infrastructure.
Thank you. Okay, Robert, you would like to go next?
I'll just say that I think what is important in this work is to make sure we have a very healthy dose and a realistic view of what the operational challenges are, which there are many, and really ensure that we don't miss understanding technically what we need to achieve and what certain technologies, their capabilities. I mentioned this earlier as well, wrapped up in our ability to understand, quantify, and manage the risk associated with it. I think there needs to be a very clear understanding of the regulatory framework and path to enable these operations as well, PK, to keep us all incrementally moving forward, but in realistic scenarios that can actually be implemented.
Thank you, Rob. Let's see. Okay, go ahead, Heidi, please.
Just echoing what my colleagues on the panel have shared already. I think they've really hit the high points with the CNS and the requirements and standards that are going to be needed there. The only other additional item I would remind folks, and I very much agree with the community involvement and collaboration, but also really key here is involvement with existing NAS users. So folks from the manned community who come with historical perspective, very ingrained and passionate views around our current airspace structure and what it looks like moving forward. I think they have to be a key piece of this as well.
Thank you, Heidi.
I would tie to what Heidi said and say there's a reason why we have the safest airspace system in the world. There's a lot of effort that goes into that. And so safety as a consideration first. How do we get to yes safely is the question that we have to pose to this group. We certainly want to enable operations, but we have to do it responsibly. Our decisions should be risk-based, sound logic, and we're going to have to defend these internally, publicly, and politically. So I think that's our, if we had to say, how do we do this? We integrate instead of segregate, and we make some very sound decisions in how to do that. Safety first.
Thank you, Will. Anybody else?
PK.
Yeah, please go ahead.
Yeah, sure. This is Lisa. Yeah, no, I agree with everything that's been said. I would just stress, I know Rob mentioned the technical, kind of getting the technical framework and understanding of all the technical requirements, as well as understanding the full regulatory framework and all of, everything that's going to need to happen in a really fulsome way. So from the FAA perspective, from all relevant federal agency stakeholders, and understanding what are the barriers to getting from here to there, and how can we enable this and move forward diligently but safely. So again, I agree with what my colleagues had to say, and look forward to supporting the work of this group.
Great. Thank you so much. I think we are out of time, but I'm happy to give someone last comments here. But we have spent the entire time in a very productive manner, and I apologize if the audience didn't get all the questions answered. But this is, again, I will reiterate, this is the kickoff. This is not the place where we were all interacting together with each other, but this is the beginning of the conversation. And there will be work group where you will be given opportunities to be part of that, and it will be truly collaborative innovation that will occur as we have seen in the prior NASA project. So we look forward to working with you, and on behalf of the Advanced Air Mobility Project, the mission, all the NASA centers that are working in our headquarters, I really thank all the panelists and the audience who participated that. I particularly want to thank our IT support, Ash Khan, and the number of folks and the team that put together this: Ash Khan, Richard Walsh, Brianne, Cecilia, Anna, Alina, and a number of other Mike Chairidis. So a number of folks that actually helped, Keith, number of folks that helped put this together. So I appreciate that. Thank you, everybody. Also, Mike Patterson, I see. And look forward to continued relationship and engagement with all you all panelists, as well as the audience and the community, to kind of build the future together on the airspace. And again, we want to make sure that the airspace system will be ready, the technology and the research and procedures and all that, when the new vehicles will be ready. So thank you all for participating, and have a good rest of the afternoon. Bye-bye.